In today's Quick Science by Iseritz, we are going to learn about Thermodynamic Square. I promise you, this talk would definitely save you a good amount of time and energy from going to thermodynamic classes. Before beginning on how to use Thermodynamic Square, let us know a bit more about it, shall we? This mnemonic square is attributed to the Nobel laureate Max Born, who was grandfather of hot pot singer Olivia Newton-John. Sadly, we don't have a chance as she is already married and most importantly her age is 71. Even her daughter is 34. Moving on, several conventions are followed. Here easiest one is given. Perks of learning Thermodynamic Square: it saves your time, energy and brain memory space to remember a heck lot of equations. Remembering Thermodynamic Square requires remembering another a heck lot of thermodynamic variables, but fear not, here is an acronym for your rescue. Good physicists have studied under very arrogant teachers. Here G, H, U and R thermodynamic potential, which are present in the middle of the edges of the square. The corners are the thermodynamic state variable. Moving on, how do we use it? Here we would remember three things. First, parallel lines are equal. For example, del A by del B is equal to del C by del D. Second, diagonal lines are constant. That is, terms being pointed are constant of partial differential. Here they are B and denote a pair of diagonal and parallel have same origin. Continuing our example, it becomes del A by del B with constant D is equal to del C by del D with constant B. There is also a sign convention. Put negative sign on the side having both letters S and P. Let's start applying to Maxwell's equation, shall we? First of is Maxwell's first equation. Step 1, equate parallel lines. Del T by del V is equal to del P by del S. Step 2, make diagonally opposite to origin of parallel arrow as constant. Del T by del V with constant S is equal to del P by del S with constant V. Step 3, determine the sign and thus the final equation. Put negative sign on the side having both letters S and P, so we will put minus sign to the right-hand term. Step 4, for advanced fellas. Make third parallel line, though the center in the same direction, pointing the thermodynamic potential U a numerator and two adjacent corners V and S as denominators. Hence we get del 2 squared U whole divided by del S and del V. Going to next Maxwell's equation the second. Step 1, equate parallel lines. Del T by del P is equal to del V by del S. Step 2, make diagonally opposite to origin of parallel arrow as constant. Del T by del P with constant S is equal to del V by del S with constant P. Step 3, determine the sign and thus the final equation. Put negative sign on the side having both letters S and P, so we will put minus sign to both sides, thus cancelling minus signs, we get all terms positive. Step 4, for advanced fellas. Make third parallel line, though the center in the same direction, pointing the thermodynamic potential H a numerator and two adjacent corners P and S as denominators. Hence we get del 2 squared P whole divided by del S and del P. Following same algorithm as previous, Maxwell's third equation is derived as follows. Step 1, equate parallel lines. Del P by del T is equal to del S by del V. Step 2, make diagonally opposite to origin of parallel arrow as constant. Del P by del T with constant V is equal to del S by del V with constant T. Step 3, determine the sign and thus the final equation. Put negative sign on the side having both letters S and P, but here no side have S and P together, so no minus signs, thus all terms positive. Step 4, for advanced fellas. Make third parallel line, though the center in the same direction, pointing the thermodynamic potential as numerator and two adjacent corners T and V as denominators. Hence we get del 2 squared a whole divided by del T and del V. Here, this term have minus sign to it, but it doesn't have S and P together. While you think about it, let's solve the last Maxwell's thermodynamic equation. Step 1, equate parallel lines. Del V by del T is equal to del S by del P. Step 2. Make diagonally opposite to origin of parallel arrow as constant. Del V by del T with constant P is equal to del S by del P with constant T. Step 3. Determine the sign and thus the final equation. Put negative sign on the side having both letters S and P. Right side have S and P together, so minus signs there, and final equation is present on the screen. Step 4. For advanced fellas. Make third parallel line, though the center in the same direction, pointing the thermodynamic potential G as numerator and two adjacent corners T and P as denominators. Hence we get del 2 squared G whole divided by del T and del P. Before concluding, here's the challenge. Can you guys guess the sign convention followed for fourth step of thermodynamic square? Let me know in the comment below. Thank you so much for hanging out with me and watching it. If you like the video, give a hit to like button there and subscribe for more of Quick Science by Iseritz.